right, my name is Lundqvist. I'm system engineer in Arista. Before that, I was 14 years in Juniper, and before that in Cisco. So most of that V4 and V6 trouble that you guys earlier were give us a hard time, that's probably my fault because I was also a BGP developer for 5 years. Maybe I should start with this. This session is going to talk about a new kid on the block. In that sense, is that how a company that has experience from data centers and is going to be cocky enough to challenging those legacy dinosaurs, which is Cisco and Juniper in the peering space, and our trip doing it. So I will sort of tell you a little bit of story from we walking from A to B and where we are right now. And any questions, you don't need to have in the end. You just raise your hand and we'll try to solve it. All right, BGP peering. How many of you guys here are fully savvy with BGP? Raise your hand. Right, so pretty good. How many of you guys know about Arista? This is by far the biggest customer, so the crowd that I've seen that actually knows Arista. That's pretty good. Peter, you have done your job. Congrats. Soon you will be fat like me, right? Because you're on the big bucks. So what I'm going to talk about is the RIB. I'm not going to talk mostly on the control plane, but if you guys, it's always when you come from a vendor, there's always some hardware involved, right? Except in VMware, they talk about you can't run software and software. But if you want to touch and hug on something and see how Arista hardware is, you have it there in the end. That's a switch. I know this looks like a pizza box, but that's a core router. It doesn't need to be a fridge size, right? So that is a core router. So go to Pedro and do whatever Pedro is doing, talking prices and stuff like that. BGP is very simplified. There's a bunch of tables and pseudo tables. So local RIB is what you will install in your routing table that eventually shoots down to your forwarding plane and will be your FIB. So this is the table that people are all talking about here. But before that happens, you have a pseudo table per each pair you have. So if you have 50 BGP pairs, you will have 50 agents RIB in. So that is the table before you're doing the path compute and path selection. That's why we drain so much of memory in a hardware box. Even you guys are wondering, oh, I have 32 gig in my PC, and we think it's hilarious and pretty cool to have 32 gig in hardware. And I know that I saw some pesky customers that say, why don't you have 64 gig in your stuff? Because you need to adapt it to a radix tree. It's not just thrown in memory. We can throw in memory, and you can pay humongous for it, but you're only going to use maybe 50% of it. That's a sort of answer to you, Huggy, when you always complain about why don't you have 120 gig. Yeah, we can put it in there, but you're only going to use a small patch and portion of it. Where do we come from in Arista? We do this. We do it pretty good. All of you in here that have done Facebook and Googling, and yesterday when you were drunk, you were ordering a Uber cab and stuff like that, your packet has passed over my gear. Your packet has passed over my gear. So even you guys here didn't raise your hand, you know about Arista because your packet has passed over my gear. So don't come complain to me, stuff, I done my job. So this is how we build data centers. We don't do clusters. We don't do vFabric or I don't know what, ACI fabric or whatever proprietary stuff. We build data center with IP. And that's no mystery, right? That's what you do in the internet, right? You do it with IP. If bridging and LAN emulation never worked, I would have been out of job. So when we build in data centers, we think the best place for a VLAN is local to the box. You should never leave the box. Then it should be routed forward. Also, we believe in the concept of leaf and spine. We don't build data centers in square. We don't build them in a triangle or collapsed backbone or whatever. We're building in a leaf and spine. That means that you can grow both spine and leaf as need. We also believe in load balancing. That means that we don't really have to explain why you need to buy a certain amount of links that are not used. All links in our design or data center are using, which by the way is the best redundancy. You guys were talking about best redundancy. What is the best redundancy? That is a path that has always been in use, right? Then you know if they're living, that's actually living. Because if you're doing any active passive, you can bet your sorry ass that that passive will not work once it's needed. So I may be building an IP fabric in our data center, so you could use the link state protocol for it. But since the design here is leaf spine, the traffic path that you really want to avoid is leaf, spine, leaf, spine, leaf. Because this is what can happen in a convergence scenario with a link state protocol, because there you have floating. Everyone needs to have the same table. So by doing ISIS or USBF, it's pretty interesting where you're getting scary by saying ISIS these days, right? You feel politically incorrect. But so link state protocol is nice, right? It just had a tendency that the floating is that you can have temporary traffic pattern which is not designed. So this is how we building data center. We build a BGP. Guess what? That's what internet also built upon, right? And you also have this glory effect that you pair a table, right? So you don't have a table that everyone needs to have exactly the same. You can have policies around and do whatever, so the leaves can actually look exactly the same or totally different. So this is how Facebook and Google and Telia data centers, this is how they're building it. It looks that. If you come from another vendor, you might say, yeah, I have this glory clustering thing, I'm point and click here and there. Nice. That works when 3 nodes are in a triangle or in a square or something like that. But this is how the data center looks like today if you have been done Googling on Facebook or whatever you're doing. So what were we good at? So I joined Arista 3 years ago. Most of the engineers there were pretty savvy in Hadoop and VMware and OpenStack. So they always thought that was pain in the butt. So they gave me this. Don't worry, I'm not going to do a full multi here. So this is the T-shirt you get when you're on a routing team in Arista, right? So I usually wear it just to bore them out. So our BGP implementation, when I joined the company, didn't even have 4-byte AS. So we had done particularly significant adventures after that. So by default, for instance, multipath, if you're really savvy into BGP, if you turn on multipath, it will only work if you see in contiguous routes from the same AS, right? You need to turn on a certain flip in an operating system to have load balancing. Our default is load balancing, because we believe in ECMP that that's the best routing protocol itself. So this is one of the differences to others, which means that this is by far how Arista data center look like. You see there are certain routes that go into a virtual node or a bare metal or whatever, and you have a month of paths to reach to it because you route to the destination. That means that we also, for others very advanced features that other vendors like doing this BGP pick, that is actually multipath, but with 16 lines in the code, we just say, please make it passive, and if the primary one fails, then shoot it in. So these stuff that take endless in my previous role in Juniper just took us a couple of hours. In the best of world, a data center has the same speed, leaf spine. All makes sense, right? Because you're going to hash the traffic from leaf to spine, and then it always makes sense that you have the same speed. That's your idealistic world. You can bet that there are some links going down, and then you temporarily need to use another speed interface. Then our implementing can actually adapt to that, so we can sort out the hashing, so that if you have a 10 gig link and a 100 gig to a spine, 10 times more of the hash sessions will go to the 100 gig link. So these are the stuff that's going on if you're doing BGP in a data center. So it's not that we are totally infinite. We sort of have some skilled when I joined the company 3 years ago. But what to do next? We don't do our own ASIC. How many people know what an ASIC is here? Raise a hand. Wow, there's a whole bunch of hardware geeks here. So it's actually so frozen software to do with repeatable actions. That is say that don't try to do the magic. These are the stuff that you're supposed to do. And then you burn it into some silicon, and then you sell it out. Usually it takes 6 to 7 years to develop an ASIC. So when Juniper, Cisco, and others build their own ASIC, there's a tremendous amount of effort in doing it. and roughly there are 67 bad burns before you have the ultimate product, which means there's a lot of money going down the drain. Well, you are the guys that are going to pay for it, right? Because they will not, right? They just charge you extra. We don't do that. We let the people that are good in doing it. So we buy from Broadcom and Intel and stuff like that, and we optimize the software on top. So you can see that we use sort of like McLaren, right? They don't build their own engines. What they do is tune in the chassis and tune the engines. That is sort of Arista. Is Spotify here? Oh, thank goodness. So Spotify is one of the first customers that, okay, we have you in leaf and spine. 100 gig interface is pretty costly because Cisco say they want to have, refrigerator-sized box to have 4 times 100 gig. You have 6 100 gig in a pizza box. Why can't we use you? So we look at it upon it, right? So Spotify in a data center, they have a transit at least, and they have a couple of private pairing, Google, Facebook, or whatever, and they have at least 2 links going down, right? So this is what they need. Do they need full feed? Yeah, I mean, full feed is pretty nice on the control plane, because then they can make stats of which user is going where. That's what Amanda was talking on the control plane yesterday. And by the way, in their data center, they run v6, right? So I'm not really sure what it's a front end they talk v4. So what to do about that? Well, we add filtering capability, which means that we filter the routes needed to be installed in a forwarding plane. Because merchant ASIC 3 years ago, at best, could have maybe 64,000 in the forwarding plane, but 4 million in the control plane, because that's just CPU, right? So these were our first walk, roughly 2 years ago, to entering the BGP edge, to being a peering router. Those cool routers that you attach to this glorious exchange point. That means that we need to do more features, because when you're doing path selection, if you're going to advertise the route further, you're only going to advertise the route that was best fit that you picked, right? You're not going to pick every route. That means also we had to implement features that to the controller plane advertise all the routes, so their fancy PMAC that also has S-flow could do calculation in case they want to change what routes are installed on the forwarding plane. So, okay, then we have to do that, and we did it. Then, 2 years ago, stuff changed, because it doesn't take 6 or 7 years for Broadcom to build a new version of ASIC. They have 4, 5, 6 all the time projects going. Meantime, Cisco, Juniper, or someone else maybe have 1 or 2 projects. So when we did this with Spotify 2 years ago, at the same time, suddenly Jericho come up. And Jericho is a whole different beast. In brief, that is an ASIC that has 2 tables. One table is the LPM, sort of a radix tree, a route table. At best can have roughly 300,000 routes. How big is internet today? Oh, yeah. Million. Are you sure? I would say slightly under 700K for V4, and a little bit below 32K for V6. But what do I know? Am I just a vendor, right? So the trick here is to move the routes to the dumb lem table. And a lem table for a switch vendor, that is a fixed size. That's where they store your humongous amount of MAC addresses. So you don't need to be the smartest guy in school to find out, okay, which are the most common prefixes. Maybe I should to the V6 part, or brown sound, do you see? To find out what is the most common prefix for V6. And in this case, it was /48. So just pull them into the lem table. Easy piece. You just say, this is how to do it. And then now suddenly you have a full feed in a box that are sized like that, a pizza box. That's not good enough. Some customer liked it. If you are David Barroso and instead of speaking Swedish, you speak in Python. But for other more humans, why can't you do it automatically? So the next thing we did was advanced algorithm, and also, of course, with baseline internet. So we're having this knob, IPv6 hardware fib optimized profile internet. Then they do it all for you. So a combination of seeing what you're receiving and what we're knowing, those routes automatically move to LEM. And by now you have a pizza-sized box that has 1 to 2 million in the forwarding plane and 5 or 6 millions in the control plane in the rib. So now we have a peering router that is not the size of a refrigerator. That's not enough still. When you're building a data center and you had, remember the multipath that I showed? People don't really care about seeing path selection or statistics, right? It's not needed, right? As long as you have 4 or 5 paths to reach something, good enough. Then the data center jockeys really don't care. But you guys care, right? You want to see where certain paths are selected, or if you have retransmission in a BGP session. So the next thing we have to do, I thought that going into the bash and typing, that's -p, then you get all the TCP statistics if you have retransmissions and stuff like that. But so what we did is we added all that stuff into the CLI. The game with that is that we have customers that primarily looking with JSON API or netconf or whatever, they're looking at these parameters. So if they see, for instance, that the RTT is changing, then they react on it. Okay, pretty interesting feature. Next thing is that people were not happy about my path selection. They actually want to see stuff, right? Again, in a data center, you really don't care. You really don't care because everything there is load balanced, right? But if you do peering, you want to see why a certain path being selected. So you should imagine how much of time we have spent on having some form of good explanation why a route is not selected. You think this comes for free. I can tell you this is by far the most heaviest stuff I've done in my career. The code is as exciting to see that paint going dry in a wall. If this, then do that, print that. And by far it's probably 64,000 lines. So I hope you guys are happy because this was really hard work. Being a new kid on the block, you face religions. And in this case, regular expression is a religion that I didn't know. I didn't know there was a religion for, you know, there's Catholics, Buddhism, Muslim, Jewish, all that stuff. But there is also a religion in the internet space called regular expression. And the religion is if it's ASN mode or string mode. How many of you guys know what I'm talking about? I raise a hand. Yes, usually it's 1 or 2. Okay, so in ASN, that means if you type in 645, as in this case, it only gets hit if you have an AS number that is 645. Not part of anything. It needs to be an AS number with 645. Why is that? Why is that knowing to know, right? That is if you have done some very advanced regular expression tools, you need to know if it's ASN style or if it's string style. On the opposite, if you have string, if you type in 645 in a regular expression, you don't care if it's an AS or not. As long as 645 is in your AS path, you get an hit. So this means that if I'm coming around there, or actually Pedro, with his box, try to sell it, and without knowing if this is ASN or string mode, the regular expressions will be treated totally different based on what type of religion you fancy. So this is also one of those things that you guys don't care about, but makes me sweating, because we have to discover, okay, what's the most popular one? Yeah, that's probably string, because this is default in Cisco. But hey, Juniper has 40% or more of the peering space. Oh wait, then we need ASN. So a simple project of 1 week is 16 weeks, just doing both of these modes. You guys think I'm just complaining. I'm just showing my experience for the new kid. Why are you laughing at Lindeberg? You're just selling. You have never shared the pain that I've been doing. All right. But usually this is not that heavy, right? Regular expression is not that complicated because these days you guys just bring it on for the peering DB and then that's it, right? I will come to that. Protect your rib. It's an interesting thing, actually, and people are still laughing about it. When you enable BGP in Arista, we install a maximum prefix of 12,000 routes. That's default down. I hope we're never going to change it because it's pretty cool. Because earlier we had switches where 12,000 prefixes was, oh shit, I mean, I have this T2 ASIC, but it can best hold 6,000 routes. But 6,000 routes in a data center, that's pretty much. If you have more than that, you have done some worky things. So, okay, we need to modify that. And then we come into the second religion here. Obviously, people were not happy by just resetting to the TCP session, because that's what we did, right? They want to have a timer for 1 hour so that your NOC can wake up and suddenly, call someone and asking, why have you 2 times prefix suddenly? We have shut you down for 1 hour. The second religion was that should you tear down the session based on that the routes were all your routes you learn, which is before policy. So if you have a policy here that says that I'm not going to accept anything longer than /25 or /56 if it's V6. So if everything on top, drop it. Should that be calculated? That's your policy, right? That's not your customer's policy. Or should they instead be acting on after your policies, what you have accepted, and then kill it? So guess what? This is what we have to do. We're doing both. So please, both people. So this is the pain when you are a new kid on the block and you need to do stuff and make people happy. I really don't know what each is default here for Cisco Juniper, but I guess there are the conflicts is there. So, scaling of policies. Now the really pain begins. Sometimes the pain it has a person. Usually they are named Fredrik. Whenever there's a person called Fredrik, there usually is a problem. That's my experience, belonging to both engineering and to actually pre-sale. Whenever there's something that has Fredrik, see that sort of like a marching route. Try to walk around it, avoid it, or pretend someone else. So having a normal way of doing route maps was not good enough. So we have to do reuse policies. His words were reuse, reuse, and reuse. Or 3 times reuse. I don't know what that means. Maybe that's like 42, a secret code. I have to read that book again. So essentially what it means is that if you have a policy where you're going to knock out RFC 1918 routes, it's pretty boring if you have 100 peering sessions, right? Because you need to have the same lines on 50 places, right? So seems to be what people want to do is they are lazy and they have bad auto-provisioning or something like that. So if they have one table for RFC 19, one table for margins, then you should add that like a sub-route map. So that's what we had to do. So you create your 99 rules and you call it from your policy. And then if your market table looks like this, by applying this stuff where you have, what you mark, you go to peer, and sorry, by the way, this is V4 examples, right? But if you go in and see into that, okay, what are the RFC 19 routes, what are the marching routes, and what is my policy, how much longer prefix to accept, and then adding, of course, the humongous amount of regular expressions, then you tail them away and then it looks sane and healthy. So these are also the stuff that we needed to do. So what is our gain, really? So far, everything I've been talking about is more like catching up, right? You have seen it before in some other vendor, right? So what is Arista good at? There's one thing that we are better than anyone else at, instead of T-shirts. That is auto-provisioning. We know how to handle configuration large scale. How many of you guys have a CCI certification? Raise a hand. 1 or 2. All right. How many has a GNCI? Oh, yeah, of course. You are alumni, right? You didn't do any test 15 years ago. So in a data center, having skilled people that exactly know the CLI, it's not that common. Usually there's a contractor that do that stuff. So all the configurations in 150 switches or 1,000 switches in a large data center, that needs to be automatically created. Zero-touch provisioning. This is what we are good at. So this is what we are bringing to the table. So imagine that you had that, remember the Spotify solution, where on maybe on a daily basis, you need to change the prefix list, what you're going to install, because your policy, now you're going to point to certain routes to maybe to, God forbid, to NTT instead of 1299. then you need to change your prefix filter, right? Those prefixes should go there. That can be a humongous amount of list. Is that really needed to be in the CLI? Do you need to have 50,000 of prefix list in the CLI? Just because of you want to type a show command and see them? No, you don't, right? What you do instead is that you put them into a file, or you collect them from a server with netconf or eAPI or whatever your fancy remote protocol is, if your security geeks allow it, and then you download it to the box. That means your auto-provision system can change on an hourly basis regards with policy, how you're going to weight something. So if Spotify discovered that certain users has problem, if the path is through Telia 1299 transit, then actually they could swap the entity by just changing the whole of these policies and filters. That's pretty nice. Next thing is regular expressions. How many guys here has downloaded a regular expression to a router? Jeez, wow, you're lucky. There's a lot of people that don't know the pain. In BASIC, these are lines up to 5,000 or 10,000 long, right? A humongous amount of lines. Usually you download it from PeeringDB or something like that these days. But in my early days, you get paid good for typing in one by one, right? But these makes the configuration of peering box from, if you have a leaf router, maybe it's 2 A4 pages to 42 A4 pages. And these are the regular expressions that's the illness here. So why don't try to do the same thing? So we knocked our poor heads together on Arista and thought we need to do something about this. Because we did tests, and the same ill person named Frederick kindly provides us with 7,000 or 8,000 line of AS regular expression, a real-time configuration, not something that we had done in the lab. And we download it to our box and click it. 11 minutes. 11 minutes it takes from that we start to download it to it's there. So 11 minutes it takes to change a complete configuration for regular expression. Is that acceptable? So another way, so why does it take too long? That's the next question. Well, the problem here is that in our case, our CLI is actually Python. So it's a line-to-line translation, add. That's why it takes these humongous hours. Other implementation has a full-blown GCC compiler when it shoots down this stuff. It simply is that you take in and then you have to reel it line by line down to the configuration. That's why it takes a humongous amount of time. You come through CPU on it, and you maybe win a few seconds, but you don't win minutes. So the way to do it is to play the same trick again. Put them into a file, and then call them from a file. That means you take, in our occasion, Python out of the equation, and now it's C++ they're doing it. So now you can download configurations of 8,000 lines down to fraction, down to 1 second. So these are the stuff that we do in Arista. These are the stuff that makes that, our value again from going just being the new kid on the block to actually being someone that is worth it, that adding something different to this. And then, of course, we have something else different. Pedro, maybe you can bring me the box there. Nice to see that he works for me for a change. So this is a peering box. Maybe it looks like a switch to you. It has 6 times 100 gig and 48 10 gig ports. So this is, well, yeah, you can show it, and this is your 50 minutes of fame. So this is a box that you can do with it. You can try doing it yourself. We have customers actually that use our box. Well, it's a Broadcom, and in a sense our SDK, and then running Bird or Quag on it. Then you make me unemployed, but I'm happy on your half because I'm doing only software. But this box here totally changed the whole game because no longer you need a box at this height. Now suddenly it's a pizza box. This box could be an exchange point. So everything in this environment are changing. And what is changing here is that for the first time, really, the software is the most important thing. It's not really hardware. Because this stuff You buy them from Broadcom. Then, of course, it's a pain in doing software apply on the ASIC, make them stable or work better. But these are the stuff really that makes a change. And ultimately, it will take it down the cost for you, because the equipment actually get cheaper. That's it. And cheaper and cheaper. Well, I have to make my living also. Right. Any questions? What are we missing? No V6 question? Oh, of course.
Microphone over there, please.
Oh, yeah. Here it comes. Oh, yeah, shoot.
So Michael Abrahamson here again. So what about like Netconf and so on all of this? Or are you looking into... So the classical thing is, you said about adding line by line. What if you have the entire file there and you basically do like a commit for the entire 8,000 lines? Do you still have the same problem? Or does that work around the problem? Or do you actually have to go this file approach?
First to answer the question, what APIs we supported. Netconf for me is just a transport, right? It is a young modeling that has a gain with that, right? So, we understand that the operators fancy that. The data center guys, they like Python, RESTful APIs, API. They don't know shit about Netconf. So, of course, we have the same problem as we're doing both. So to answer your question, where you're going to have the configurations, you can have it on your controller. And that will be a massive amount of file. Well, a massive amount of file. I don't know, 8,000 lines. That's not really a big file, right? Or you have an interact link where you shoot it in, right? You can do that. Will that be faster than having the file locally? No, it will probably be slightly slower because you add in TCP into it or whatever mechanism you have. But by far, it would not be 10 minutes.
Yeah, so the big problem here is to be able to parse everything in one go. That's the...
Parse everything in one go, that is one of the problems, right? Because you compile every node, right? So if you're going to make it fast remotely, then you Yang model it, you have the configuration, and with netconf, you shoot the whole configuration. That will be exactly the same as have the file locally, not doing line by line.
Then I have an IPv6 related question.
Of course.
So if you're doing Anycast, how do you make sure that the ICMP error message for the PTB message for PathMQ discovery gets to all the hosts, all the Anycast nodes?
All the hosts of that. How running Anycast and exchange point? Or is that a generic question?
It's a generic question.
That's difficult.
So some are saying you replicate the ICMP error message on all the ECMP paths or all the Anycast paths. Some others are saying, yeah, this is vendors don't have a solution for this problem.
I don't believe any one vendor has a solution for a problem because inbuilt what you're talking about is something usually you inherit from the kernel, from the Unix kernel that you base your operating system on. And most of them today doing replication, sadly.
Yeah, but basically you as a router, if you have 5 paths, you have the same thing. These are now directly attached hosts. So this is BGP multipath. Let's say you have 4 of them.
Right.
So the important thing is the TCP session need to be hashed. The ICMP P2B message need to be hashed the same way as you do on layer 4 or whatever for the session that this belongs to, or you just need to spray it across all of them.
It needs to be, today it is to hash to a session.
Okay. Do you think that you do that today, that this hashing is
I know
the same?
that we're hashing to a session.
Okay. So
I know it's, because you need to be pretty careful here, right? Because there are more problems in the path, right? It's a little bit higher problem. Should you only pair with local address? Or should you have a unique link address? Because you want to have BFT to someone, BFT to something else, right? So, do you know what I'm saying? It's a little bit of a design question. I guess you want to have a miracle for everything. Then, yeah, I don't think we have. But today, the hashing is what it is. That's what we build upon.
Okay.
Doesn't matter if it's control plane or it's a forwarding. for good and bad, I would say. So one of the problems we have, for instance, let's say that you have fragmentation. So that needs to go up to the CPU because suddenly you have fragmentation, right? And when the CPU then is looking upon the program and then it's going to take it down to multipath, this is a new session, right? Then that will only go to one link. So that is one of the biggest problems if you totally rely on hashing. Because if you do fragmentation, then you're out, right? I mean, this is one of the problems. And for instance, in CDNs, when they have a lot of V6 tunneling instead of having their own network for the data replication.
Time for a couple more questions, if anyone has it.
Feels like I am the guy in front of lunch menu, right?
Okay. Well. Okay.
All right.
Well,
thank you.
Thank you very much, Peter.